on the picture fractals that we learned about in the book, and how they're infinitely detailed, and they don't just stop at what you can draw. You can see that one zooming in. This is one we found on the internet, and then we made our own once it loads.
So, as you guys all know, we saw in the book, fractals are images that are intimate,
It's really cool.
yeah, it goes faster, are infinitely detailed. Through magnification, you can see even more detail in the fractal, which just happens to look like the regular picture that you just see in the very beginning. We have a script.
What does that say?
Fractal.
Oh, it looks like a T.
There's a T in fractal.
Not the first letter. As you can see, it's just a picture within a picture within a picture within a picture, and it's just continually zooming in onto the next picture. So it continues on forever while it's zooming in.
And the picture fractal concept is actually like the same type of concept as the two parallel mirrors. That was also we had read about in the book. If you have two mirrors next to each other, if you see, it looks like they go on infinitely, obviously with light, but the thing about light is that it can only travel at a finite speed. So if you were to see, if light, didn't speed on infinitely, then you would be able to see, the infinite mirrors. And it's the same concept with this. It's just a smaller scale. It's the same picture at a smaller scale.
With this, it seems like we can grasp the concept of infinity more than just throwing out numbers, like this number sequence is infinite, and then that's all we're told. We never actually see that it continues to go on forever, but with this, you can just sit here and watch it all day, and it continues to go on unless your laptop dies.
Very true. So yeah, we wanted to show that fractals are fun by making a picture like this, and Michael will explain the process of how he took this picture.
I used my Canon T2i to take a picture of it, then brought it into Photoshop to convert the raw image to a GIMP, JPEG, and then I brought it into GIMP, making a multiple image layer, creating the GIF, while increasing the size of each each frame, and then I exported it, and now it's there.
Nice. So it's not as complicated as it seems.
Hooray!
Hooray!
Any questions for them?
I have a question.
Yes.
Why Allie? Why did you choose to make that go on?
Because Coke is what Georgia is known for.
Okay.
And the red background looked good everywhere in the light, right?
I understand.
Okay. All very good. Thank you.
Oh, you just missed it. You just missed it, seeing that. Thanks.
Sure.
I did that on purpose.
We
We
know.
know.
Perfect.
Yeah, I just want everybody to know that I don't just have sweatpants in my wardrobe. I actually have real clothes, I promise. 8 a.m. is just very early for me. Okay, so I'm going to start off by asking a question. Has anybody ever seen a show downtown at like the Fox or the Alliance Theater?
Yeah.
You have.
Yeah.
Anybody else seen like a show at the Fox or something? Okay, somebody who's not Steven or Allie. Tell me what it looks like. Like, tell me how the stage is shaped.
Like that.
Yeah, it's
Yeah.
shaped like this, right?
Ooh.
I know. Christian, at least.
I know.
I know. Okay. So the Fox or the Alliance Theater is shaped something like this. It's very tall, it's very straight, it's very long. This is what's called a proscenium theater. anybody seen a show at Berry College here?
Yes.
Yes. You, somebody who's not the, again, Stephen or Allie. Tell me how that is shaped.
Like kind of like that. Okay, anyway, it's kind of shaped like that. It's kind of, I don't know how to describe it. It has like the circular, it like jets out into the audience.
It juts, it's called a thrust, right? Okay, so thrust is very similar, you're right. But it actually ends up looking something like this. Now, please, people, forgive me for my very quickly done drawing here.
Bad stage design.
Oh, shush. Design not bad taste. Obviously, since I'm presenting on design. Okay, so it looks something like this, right? Oh no, that's not a straight line.
Just go with
You
it.
guys get the idea. And this is a thrust. Okay, so when I was in high school, I was a horrible math student. Horrible, and I cared about nothing besides theater and film. A lot like now. So, I was in geometry in the 10th grade, and I sucked really bad at it, okay? I was terrible, and I had to relate everything to something else. In the 11th grade, I wrote a song for, it was I Just Can't Wait to Be King, but I used it for algorithms. I was so horrible at math, and I had to learn ways to do this. So the way I learned how to memorize what legs and a hypotenuse and a triangle were was like this. In a proscenium house, we have what's known as wings. And if you've been like dance concert, you know what this looks like. Wings like this, right? And it's for the actors to go in and out and off and backstage and stuff like that. And when you have wings, what ends up kind of happening is you have this sight line that looks a lot like this. Something like a triangle. And I always knew, okay, the wings, the individual curtains, are called legs. So I always remembered legs, and then what's known as the apron, what's on front of the stage, is where the hypotenuse is, right? And I thought, well, that's where all the hype is, right? That's where you're looking at the hypotenuse, right? Okay, so that's where I remember things. So when thinking about this project, I was like, I'm terrible at math. I have no idea how I'm going to relate my math in my life. Well, I'm in technical theater, and there are a lot of triangles and geometry in technical theater, which was very intimidating for me when I first got here, but I've learned to get used to them because triangles are my friend in technical theater, and we need them, they're important. So I'm going to tell you how we build a show, an average show here at Berry College, using right triangles. Now obviously this is not a right triangle, but it just helped me out. It's a starting point. So the first thing we do when we build a show is we have to think of a design. Once we think of a design, we draft it. It's like an architect. We have to sit down and we have to draw a bird's eye view of how the set is going to look. And we use an architect's right triangle for that. Look at that. I know. Holy crap, it's awesome. So yeah, I used this little bugger a lot last semester when I was drafting a stage design class. It was terrible. But anyway, so this is something that I used a lot. So once we use this and we draft all of this stuff and make it nice and pretty, we have to go into the construction point, which means we hand all of our drafts over to people who work in the shop, and they develop and build this set. And the way they build this set is a bajillion different ways, of course. But we use a lot of triangle tools in order to build this set. Like a speed square, haha. No, I know this is not a square, it's a triangle, but we say square for everything because we're trying to make a square corner. So a right triangle, okay? So we use this a lot to like mark up against 2x4s and mark a straight line down the middle so we can cut it. So I'll talk about this in a minute. Don't fret. Seriously. Thank you, Stephen. Keep calm for me, will you? Keep calm. Okay. This is what's known as a combination square. It's something very similar to what the this bugger over here is. We land up against 2x4s or other pieces of wood or masonite probably and mark things off. So we can keep it like that. There's also a level on here, which is unnecessary. So anyway, that's how we cut things with squares. And then there's a lot of technical elements, a lot of things that we build that are and eventually become triangles. I can't bring a lot of them in here. But I'll show you one. This is a leg. This is what we put on platforms. And obviously we have these nice pretty right triangles because what we do is when we have to put them on platforms, we have to put the platforms open, we cut them up against the hard right corner of every other one. And we can't drill this through there, so we put these little triangles on there. And then we also, I don't know if you can tell because this is an old one, if you guys can see, we also drill in a triangle because it's the most secure way for us to drill the legs into the platforms. See, they're everywhere. I know, it's crazy. There are also bigger things that we use that I couldn't bring in, and stuff that actually we don't use as often at Berry just because we don't normally build things like this. But there's something that's called a jack, which is a giant triangle. And it looks something like this. These would be my like straight lines. Put impressions on here. So we build it just like this. And we lean this up against flats, which are these big, tall canvas things to hold up scenery. So if you ever see like, oh, a painted brick wall, those are a bunch of flats. And behind them, I guarantee you, there are jacks all down the back. And they're big, giant triangles. Look at that, they're everywhere. The best place, and the place that actually helped me the most in this class where there's a triangle, is in lighting land. I'm going to erase this. So, in our theater, where we hang the lights, directly above the stage and above the audience, so the next time you go, you can look up and say, oh, look, there are lights up there, is known as the grid. And in our space, it's known as the space. It's 12 feet from the floor all the way up to the grid. However, the average person is obviously not 12 feet tall. The average person is about, it's actually 18 feet. So this whole thing is 18 feet. But the average person is about 6 feet tall, right? So there's really about a 12-foot difference. So when we're hanging the light, if we want to light their face properly, we stand where the actor stands, and we say, okay, I'm about 6 foot, give or take. So there's about 12 feet in between the top of my head and the top of the grid. So then we go up, and then we go 12 feet back, just like that. Make a nice right angle like that right above my head, and 12 feet back exactly is where we hang our lighting instrument. The one that we use the most is called the Source Forge. And it hangs directly in front of them, and that guarantees that we are going to light the actor's face, no matter where they are within the circle of light. So what ends up happening is it looks something like this. We go 12 foot back, and we have this nice, pretty lighting instrument, something like that. Shh, don't make fun of me. Jesus. I'm doing this on the fly. Come on now. It ends up making this nice, pretty, right triangles. Look at that. And that's how we do all major lighting. Now, of course, there's side lighting. And side lighting is actually done very similarly. We go up, and then we go 12 feet to the right. Go up, and go 12 feet to the left. And all that kind of stuff. Now we have fake bar cans on the side that are completely different. We don't actually do right triangles. But for the basic stuff of lighting, the general body of the actor within the space, we use a right triangle. So they're everywhere. I can't escape them. It doesn't matter that I was a terrible geometry student. I'm always going to be using triangles. So I guess I just have to get used to them. That's okay. Is there any questions? Maybe. Yes.
Can you do a monologue on triangles?
No, I'm a technical theater.
Oh, okay. What is a technical theater?
A technical theater person is a person who builds and designs and anything from set to the costumes, or direct, which is what Sydney wants to do.
Ooh.
I do not perform any way, shape, or form. This is the most you're ever going to get out of me. So, the end.
What about the conference room then?
That is a special case. Thank you very much. Any other legitimate questions? No? Then the end. Technical theater and triangle.